This is going to be our introduction to exercise 6E, which is on cubic functions, and we're actually going to start graphing cubic functions. But first, this is our do now question from exercise 6D. So find the roots of the cubic equation x cubed minus 6x squared plus 11x minus 6. Now, obviously we know that the word roots means to find x-intercepts. Now, graphically that means to let y equal 0 and find what those intercepts are. Algebraically, it just means solve it when we let it equal to 0. So in this case, what do I have to do first? Anytime you're presented with an unfactorized equation, we have to factorize it. Thank you. So, anyone have any ideas what numbers I should pick? 2? Okay, where'd you get 2 from? Who said 2, sorry? There? Okay, 6, perfect. So we're looking at factors of 6. It could be 1, 2, 3, and 6. Now, it can be positive or negative versions of all of them. So technically, we have 8 options right off the bat. Let's start. Actually, I'm going to ask you, should we start with the 6 or the 1s first, if we're testing it? Why 1? It's easier, right? So let's go ahead and let's try positive 1. So x plus 1, equals 0. Or rather, x plus 1 is our factor. If I let x plus 1 equal to 0, I get x equals to negative 1. Now, do I go through the whole long division now? No, I just put in a remainder theorem and see if the remainder is 0. If it is 0, then it is a factor. So let's put that in. So I get p of negative 1 equals to negative 1 cubed minus 6, negative 1 squared, plus 11, negative 1 minus 6. There we go. And that equals to negative 1 minus 6 minus 11 minus 6. Right off the bat, is that equal to 0? No, we can just tell right off the bat they're all negative numbers, so that does not equal 0. We can move on. Let's try x minus 1 equals 0, and therefore, actually I'm going to use a different color so we can show different attempts. There we go. X minus 1 equals 0, and therefore x equals to 1. Let's try p of positive 1. So that's 1 cubed minus 6 times 1 squared plus 11 times 1 minus 6. From there, you get 1 minus 6 plus 11 minus 6. Does that look like it might be 0? Yeah? Awesome. If I go ahead and let's add up the negative numbers. Minus 6, that gives me negative 12. 1 and 11, adding the positive numbers gives me positive 12. We know that equals to 0. Perfect. So I know that this right here is a factor, x minus 1. But it doesn't say find the factor, it says find the roots. So we have to continue factorizing. This is a bit of a longer question. Oops. Okay, so from there, I'm going to do the long division. So x cubed minus 6x squared plus 11x minus 6 divided by what we said was the factor, x minus 1. From there, I'm going to think, what number do I have to multiply x by to get to x cubed? Or in other words, x cubed divided by x, which is x squared. Thank you very much. X squared. Oops. X squared. There we go. And I'm multiplying, so x squared times x gives me x cubed. X squared times negative 1 gives me negative x squared. Once again, it's an implied, thank you very much, implied negative. So I'm going to write x cubed, take away x cubed. That gives me 0, obviously. Negative 6x squared, take away negative x squared gives me negative 5x squared. Thank you very much. I'm going to bring down that positive 11x. I'm going to go and think what number multiplied by x gives me negative 5x squared. That answer is negative 5x. So I'm thinking, well, negative 5x squared, as these two numbers multiplied by each other. And then negative 5x multiplied by negative 1 gives me positive 5x. Implied subtraction. And I get positive 11, take away 5x, gives me 6x here. Bring that negative 6 down. And I think what number multiplied by x gives me 6x? I know the answer is positive 6. And therefore I get 6x, 6 times, negative 1 gives me negative 6. And we can see that the remainder is 0, not 6, 0. So this value right here is my quotient. So I can rewrite this question as x cubed take away 6x squared plus 11x minus 6 equals to x minus 1, which is our divisor, multiplied by a quotient, which is x squared minus 5x plus 6. Now, hopefully, you guys did your holiday homework and are generally quite familiar with the process of long division. I'm going to go through that later in person if you need to, but for now, I'm going to go through it assuming you guys know it. Now, can I actually solve my values of x from here? No, I have to simplify it further. Can I simplify x squared minus 5x plus 6 in a nice, easy way? What method? Thank you very much. I know off the bat, hopefully you guys are experts at this already. -3 and -2 work. They both multiply to -6, so positive 6, and they add to -5. So therefore, that's the same as, and we'll write that original x minus 1 from before, multiplied by x minus 3 from the first half of our cross method, and then x minus 2 from the second half. Now, we can let that equal 0 and find that x equals to positive 1, positive 2, and positive 3. It's a long process. I've said this before, it's a very long process. But the idea is that I want to test whether you are able to follow that long process and not trip over yourself in the mean. Okay, any questions about the do now question? Okay. Now is our introduction to the cubic functions in this form over here. Now, what does this form remind you of? Thank you very much. Turning point form. The only difference being, thank you very much. The only difference being it's cubed. So for those of you that don't remember, the turning point form is where y, it gives you a bracket x minus h squared plus k. Now in this case, it's cubed. So most of the transformations you guys will experience with cubic functions in this form will be the same as in quadratic form. However, there's only one major difference, and that being the shape of the graph. Now, this is our general form. What was at the center or at the origin of y equals x squared, where we just have the basic graph? Where's the middle, I'm putting that in quotation marks, of this quadratic? Turning point. What is a turning point? Lowest point, yeah. There's one more characteristic of a turning point, it's in the name. It's where the gradient changes. You guys have done gradient before, yes? Awesome. So the gradient changes as we go towards from left to right. We can see that gradient goes from negative going towards a positive value. In our cubic functions, in this form at least, our graphs don't look like this. Oops, my apologies. They don't look like this. Instead, they have this form here. I'm going to draw that a little bit better. There we go. At the center is what we call a point of inflection. Have you guys heard of the word inflection before? You know, like the way someone speaks and inflection? No? Okay. Inflection just means how something changes. In this case, a point of inflection is where the gradient is 0. Now, we'll look more into gradients and derivatives and that stuff. It's all related later on in calculus. But all you need to know is that it's a point where the graph is flat. It's parallel with the x-axis. It has a gradient of 0. However, the difference is in a parabola, it goes down and then starts going back up. In this case, it goes up, goes towards 0, and then just continues going back up. That's the difference. So a point of inflection is the quote-unquote center of a cubic function. The general form of a graph in this form is y equals a. You guys can read that. But the point of inflection is hk. So similar to our turning point form, this is, you can call it our point of inflection form if you'd like. hk gives us our point of inflection. Any questions about that? No? Okay, I'm going to go straight into the examples. Over here, I've got y equals to x, bracket x minus 2 to the power of 4. Oh, shoot, that should be 3. My apologies. There we go. So x minus 2 to the power of 3 plus 4. So I'm going to go ahead and draw my axes. Where's my turning point? Quote unquote turning point. 2 and 4. So that's going to be where my point of inflection is. So 2 and 4, let's say, is over here. That's my point of inflection. Now, here's when it gets a little bit interesting. We know that a positive parabola has a smiley face. So it looks like this. That's a positive parabola. And we know that a negative parabola is a sad face, right? Now, we know that because it's a pattern. I'm going to go back a bit and think about linear equations. And remember, we're always looking from left to right, okay? With linear equations, we know that it has a power of 1. Going from left to right, if I have a positive linear equation, which direction does it go? Top right, top bottom, up, or bottom right? Top right, it goes like this. That's a positive linear equation. A quadratic, I'm just going to write quad for now, has a power of 2. The first direction it goes when it's a positive graph, is it going up or down? It's going down. So if I'm going with a cubic function with a power of 3, and it's a positive, do you reckon it's going up or down first? Up. You guys can see a pattern, can't you? Now, we're not going to do it yet. We're going to move on to this towards the end of this chapter. We're going to look at quartic functions, which is to the power of 4. Now, can you anticipate which direction a positive graph goes? Down. It goes down first. Okay? So this is the general idea we're going to be looking at. Over here, we know that this, is that a positive or negative cubic? Positive, because if I refer back to this table over here, it's going up first. So in this case, is this a positive or negative cubic? Is there a negative anywhere here? No, it's a positive, and therefore my graph looks something like that. Now, I'm not going to go into this because I feel like you guys already know this, but if you were to find your x-intercepts, what do we let y equal to? If I'm trying to find y-intercept, let x equal to 0. That's it. Pretty straightforward. Same stuff you've already done in other graphs. Over here, y equals to 5 minus x cubed minus 2. That's a little bit more difficult. So I'm going to do the same thing. I'm going to draw my Cartesian plane, but I'm going to rewrite this equation. Would you agree that that is the same as y equals to negative x plus 5 cubed minus 2? Would you agree it's the same thing? Laura? Thank you. So if it's the same thing, what is my turning point? Quote unquote turning point. Negative 5, negative 2. So let's say negative 5, negative 2. So my turning point, or in this case my point of inflection, is going to be there. Now, is it a positive or negative graph? Negative, okay. So I'm going to do one of these. But there's a bit of a catch. That's not quite right. Let's try and find our x-intercept. So our y-intercept, my apologies. So if we try to find my y-intercept, I let x equal to 0. Are we okay with that? So let x equal 0, I get y equals to 0 plus 5 cubed minus 2. Y equals to 5 cubed minus 2. Y equals to 123. There we go. Thank you very much. 123. So my y-intercept is way up here. Now, if I let my y equal to 0, so I'm going to find my x-intercept now. I let y equal to 0, so I get 0 equals to negative x plus 5 cubed minus 2. And it's a good idea, if you're not sure, by the way, to find your actual intercepts and see if it fits the plan that you already have. I'm going to add 2 on both sides. So I get 2 equals negative x plus 5, cubed. What's the opposite of cubing? Cube rooting. Thank you very much. Cube rooting. You don't actually need to know how to solve that. You just leave it as cube root. Equals to negative x plus 5. I'm going to go ahead and take away 5 on both sides, So 3 root 2 minus 5 equals to negative x. And then I'm going to multiply everything by negative 1. So negative 3 root 2 plus 5 equals to x. I'm sorry, I meant cube root 2. So that's actually going to give us a different value. I'm going to show you what this looks like on the actual calculator. We haven't actually introduced yet, but we're going to be introducing today. Now the idea is, well, what does the word inverse mean? Opposite. So the only thing you need to know is that an inverse function just means your x and y are flipped. So I'm actually going to start over here, looking at this more complex question. We can ignore this part over here, ignore that, and just focus on this function over here. Would you be okay with me replacing f of x with y? Yeah? So now I've got 2x minus 4 cubed plus 3. equals to y. If it's an inverse, all we have to do is we switch the y and the x. X equals to 2, bracket y minus 4, cubed plus 3. Are we okay with that? Okay. Now I have to transform the equation so that y is the subject. So I'm going to take away 3 on both sides. X minus 3 equals to 2, bracket y minus 4 cubed. Divide both sides by 2. So I get x minus 3 over 2 equals to y minus 4 cubed. Opposite of cube being cube root. So cube root of x minus 3 over 2 equals to y minus 4. And finally, add 4 on both sides. So I get cube root of x minus 3 over 2, which gives me y. Oops, sorry. Plus 4 gives me y. Now, cube rooting. Now, hopefully, you guys have done index laws before in the past, haven't you? If you recall, cube rooting is the same as to the power of a third. So I can rewrite that as y equals to x minus 3 over 2 to the power of a third plus 4. Okay? I'm going to just quickly simplify that. So I get half x minus 3 over 2 cubed plus 4. Would you agree it's the same thing? Yeah. So the idea I want you to keep in mind is that for an inverse, it just means we're switching the y and the x. If we're switching the y and the x, what do you think that looks like graphically? Because we've done it algebraically. This is all you need to do for that. But what does that look graphically? Yes, Zach. Yeah, we kind of like rotate it, flip it. But what we're doing is, let's focus on that blue line there first. That is y equals to x power 3. The equation of the green dotted line in the middle is y equals to x. Y equals to x. When we flip it or mirror it across that line, it gives us the inverse graph. So the inverse of y equals x cubed is y equals x power 1/3, and that's what it looks like. It's why it looks like a piece of candy. It's because it's reflected across that green dotted line. Okay? I'm not going to go through sketching sketching the inverse of that today, but I do want you to focus on that concept. The inverse functions are found by switching positions of y and x, and also the graphic representation is that we're mirroring it across that y equals to x line. Do I have any questions? Yes?
When writing the rule for the inverse function, do you always have to write the domain and codomain?
Yes. Most of the time it'd say that, yeah. Any other questions? Okay, sweet.